After introducing the concept of the mole and the molar mass in prior videos, we are now ready to start taking those concepts and apply them to fundamental problems. In this particular video, we're going to be talking about the calculation of the percent composition by mass of a particular compound. The idea would be as follows. Suppose that you have a compound like water, H2O. Now, from our mole discussion, we know that if we have 1 mole of water, okay, then we will have 2 moles of hydrogen atoms in that compound, and then 1 mole of oxygen atoms, and that is useful. We could also calculate with Avogadro's number how many total atoms of each element we have in that particular mole of water. Something that is very interesting as well is to calculate the percent composition by mass. Okay, so if we take some mass of water, how many grams of that mass would be hydrogen, and how many grams of that would be oxygen. Okay, like that, we actually define the percent composition by mass as following. Okay, the percent composition by mass of an element X in any compound would be the mass of the element X over the mass of the compound, so I'm going to write here total, okay, multiplied by 100%. Okay, so this is very simple. You just take the total mass of that compound, figure out how much of that mass corresponds to the particular element that you're interested in, take the ratio, multiply by 100%, and that will be the percent composition by mass. Right. The easier way to solve these problems is to actually to take 1 mole of substance, because the mass of 1 mole is actually given by the periodic table. That is exactly what we call the molar mass. Okay, so our goal here is to calculate the percent composition of hydrogen and oxygen by mass in water. And again, we're just going to take 1 mole of water. We know that mass, and then we'll be able to figure out the masses of hydrogen and oxygen in that mole, and then calculate the percent composition. Again, taking 1 mole, we know that the total mass of water then is going to be the molar mass. We go to the periodic table, calculate that mass, and this molar mass of water happens to be 18.015 grams per mole. Okay. Now we can go to the periodic table again and look for the molar masses of hydrogen and oxygen, and we have that for hydrogen, this is equal to 1.008 grams per mole. And for oxygen, this is equal to 15.999 grams per mole. Okay, so then the question now is try to figure out what is the mass of hydrogen and oxygen in that mole of water. Okay, so notice that the stoichiometry, the compound tells you that there's 2 moles of hydrogen for every mole of water. Okay, so then the idea would be to try to figure out what the mass is in that mole from this molar mass. Notice that it will take this 1.008 grams per mole of hydrogen and multiply by the number of moles of hydrogen that we have in that compound, in this case water, which is 2 moles. Then we will have the mass of hydrogen in that mole of water. Okay, so this number happens to be 2.016 grams of hydrogen. Right, so we already have what the mass of hydrogen is in this compound. Now the total mass of the compound, which is water, is going to be the molar mass of water. Right, so we're actually ready to calculate what the percent mass of hydrogen in water is. Of hydrogen is going to be that mass, 2.016 grams, over the total mass of the compound. We're taking 1 mole, so that would be the molar mass. For water, that is 18.015 grams. And then multiply this by 100%. Okay, when you do that, you find out that the molar mass, the percent composition by mass of hydrogen in water happens to be 11.2%. Okay, that is the result. Okay, so if you take a sample of water, it will turn out that 11.2% of the mass of that mole of water, or that sample of water, would be due solely to hydrogen atoms. Okay, now we could actually do the same thing for oxygen, right? So we would take the molar mass of oxygen multiplied by the number of moles, which is just 1, and then take that mass, divide over the molar mass of water to get the percent composition in oxygen. But there's actually an easy shortcut to that. Notice that you only have 2 elements in water, hydrogen and oxygen. Right? So if you know the percent composition of one, then obtaining the percent composition of the other one is directly, because they have to add up to 100%. There's only two components, right? So the percent composition by mass of oxygen and water would be 100% minus 11.2%. That happens to be 88.8%. Okay. So in this video, again, we have discussed how to calculate percent composition by mass in compounds.